Our keynote speaker for this afternoon is Scott Zoldi, Chief Analytic Officer at FICO Fair Isaac. Scott will share his insights on the responsible AI in credit addressing the AI trust crisis. Scott, thank you for being here. Could you please take the floor?
Great, thank you. Can you hear me okay?
Yep.
Very good. Let me share. Okay. You can see the slides, correct? Okay.
Yes, Scott, we do.
Very good. Thank you. All right. Well, it's a pleasure to be here and to give this address. As mentioned, right, I'm going to talk about responsible AI in credit, and I'm going to address what is the AI trust crisis. And I think this is never more important to talk about it today than any other time, right? We have gone through a cycle of AI use and AI excitement that probably hasn't been matched in our history. At the same time, right, we're seeing more and more, and I'll share the statistics that customers and organizations are losing trust in AI, right? And so as we think about AI and machine learning in the use of credit risk, which is one of those areas that we have to be tremendously careful with, right? There is a challenge with how to develop models and the use of AI for credit risk and to do that appropriately. A little bit about me. I am Chief Analytics Officer at FICO. I've been with FICO for 25 years. And it's been a great pleasure to work with our clients and to apply technology, particularly machine learning technology, in new and interesting spaces. I'm responsible for more than 130 patents using machine learning and applying it to mostly financial services spaces. And so part of this will be discussing some of that work and essentially what we need from a responsible AI perspective if we are to leverage this type of technology in areas such as credit risk. Now, in 2016, I did some of my first blogs, and one of my blogs was essentially what we called the analytic grudge match, right? And this was a conversation which essentially stated that, where's machine learning versus scorecard modeling? And back in the year 2016, right, the scorecard versus machine learning debate was more around things like simple neural networks, simple decision trees. It was not the machine learning that we deal with today, which are these huge over-parameterized deep learning models. But even in 2016, everyone recognized a huge amount of potential for machine learning, right? We understood that we had alternate data sources that we could combine with traditional data sources and find new relationships and potentially improve the quality of models and the prediction of these models. At the same time, right, it was very well understood back in the year 2016 that you could build models faster, in fact, 40 times, 50 times faster than it would take to build use a scorecard model. And so, where in this space of credit scoring, where scorecard modeling and the use of generative additive models were really a founding technology for their ability to be highly performant and their ability to be highly transparent and interpretable, right? Machine learning back in 2016 was definitely being explored by many across the globe as an alternate to bring in new types of data and improve customer outcomes. At the same time, though, right, these machine learning models, even simple machine learning models, were largely unexplainable. And so we had this sort of challenge of, okay, we see predictive performance improvements when we use machine learning. And we know that we have new types of data on which we want to leverage. And machine learning is very, very adept at finding relationships that a human does not anticipate to improve outcomes. But the explainability was a huge issue. Now, since 2016, right, we've seen a dramatic change in the ecosystems, right? We have cloud providers that provide environments to build machine learning models at scale. We see they can do that in, a handful of minutes, and in a handful of minutes, you could deploy it in action customer accounts, right? Literally in an afternoon, you could build your credit scoring model and deploy it and impact customers. And that's really scary, right? And it's scary because that ability to do it versus, the can versus should is a question that has to be addressed. And in fact, I think that is why we have this customer and business sort of trust issue. These are statistics from late last year and early this year that talk about some of the trust issues associated with AI, right? And this has been largely probably spawned by, the large language models that have found their way into the world sphere, where we've seen many, many examples of bad behaviors and hallucinations, but they apply to AI generally also. So if you look in the first column here, this is KPMG doing a survey of 17,000 consumers across 17 countries. 61% are wary of trusting AI systems. 73% perceive significant risks in AI, and 75% would be more willing to trust an AI system if there were firm assurance mechanisms in place. So consumers overall are not feeling comfortable with the use of AI, right? And then the promises there, and they simply don't understand it. And they've seen many examples of AI used inappropriately, right? And in fact, sometimes in today's environments, it's okay to have very public displays of AI gone wrong, right? Without any sort of ramification. If you look in the middle column here, this is businesses that leverage artificial intelligence, not just financial services, right? But 61% are concerned about an inability to explain an AI-powered decision. This expectation goes to the very heart of GDPR, which is a very old regulation from an EU perspective, but it's a very basic sort of need that we need for any AI-powered decision, particularly ones that are life-changing or impactful. 60% lack any sort of AI strategy, which means that they don't have a strategy on what are their appropriate algorithms, how do they detect bias or enforce explainability. And it means that, 3 data scientists will build models in 3 different ways, right? It makes governance and monitoring these models very, very ineffective and problematic. And then American Banker put out their own survey of 127 bankers. 75% wanted stronger guardrails to govern the banking use of AI. 80% were concerned about nonsensical and inaccurate information produced by generative AI. And then 57% concerned about AI that introduced new ethical concerns and biases. So across the board, from consumers to businesses to financial institutions in North America, there is a large challenge with trust in AI. And this is something that we're going to have to address if we believe that AI and machine learning are the right solutions to make and advance progress in terms of credit lending and credit risk management. Now, this isn't lost on many, right? And this is some quotes that were taken out of a statement by Director Chopra, right? Which I feel are pretty appropriate in many ways, right? And 3 quotes here, right? Unchecked AI poses threats to fairness and to our civil rights in ways that are already being felt. Artificial intelligence often feels like black boxes behind brick walls, which talks about the lack of transparency, right, of many of these models that are being used. And the third one is very important also. Complex algorithms are not a defense against providing specific and accurate explanations. In today's environment, we tend to be enamored by big machines, lots of GPUs, huge models, right? But these models are inherently unexplainable, right? And we lose sight very often with the fact that these models are supposed to be simple tools to help us make better decisions so that we can service customers more effectively and more fairly, right? And so complex algorithms are really not the solution that we would need here. If we look over at the EU, where I spend a lot of my time looking where AI regulation is being developed, right? We're all aware that credit scoring is deemed a high-risk AI system. And what that means is that lenders that choose to try to use AI in those environments will face much stricter regulations. They need to ensure that the AI models are transparent and explainable. and correctly explainable, meaning that you can't just apply any generic explainable AI algorithm and say, look, here's your explanations. Right? The standard of explainability is much, much stronger, where you have to provide them an accurate explanation. An explanation such that if they acted on that explanation, they would see a change sort of outcome, right? In the ways that you would say that, let's say, improve an outcome or score. And lenders will need to ensure that AI models don't discriminate against certain demographics. And so there's a very high bar set here. And if you think about the AI trust statistics that I just shared, many organizations are not prepared, right, to meet these standards, right? Around, what are the appropriate explainable AI algorithms, if there are any? What does transparency mean, right? And how do they show that they have models that won't discriminate? And how will they do that systematically? Right, all big sort of challenges, which means that many clients that we have and we monitor in the EU are simply going to give up on AI, right? Because this is a very high bar to meet. And I think that is a challenge, right? This is where, as an industry, we need to think about what is a responsible use of AI. So while meeting strict regulation and expectations, which are perfectly reasonable, right, that we don't get to a point where we don't leverage advanced technologies such as machine learning, which will allow us to, in differentiated ways, take advantage of alternate data and open banking data and other sorts of things that could really make a very big impact on improving credit scoring in general. So we're in a crisis mode in some sense. What it means is that we have to give up on our black boxes, right? And I've been at FICO for 25 years and building machine learning models in these spaces for as long. And 25 years ago, it took a huge amount of energy to even have anyone use a machine learning model in their business, right? They simply didn't understand it. They weren't comfortable with it. You'd have to show and try to convince them that the black box is adequate, right? Today it's different, right? Today, black boxes seem to be the rage, right? There are much less sort of scrutiny of machine learning models. And this is where we have to say, for this environment that we operate in and for something as impactful as credit scoring, right, there needs to be no black box. And in fact, we need to take the job pretty seriously. We have to enforce a set of standards applied across an organization. So if you have 100 or 200 or 500 data scientists building models, they have to all build it the same way, right? There's too many mistakes and missteps that can be made that can jeopardize successful and appropriate use of AI in the scope of credit scoring. Now, I've been concerned about this a long time. And one of the things that I did about 8 years ago was started to coin this concept of responsible AI. This was well before large language models, which are not really new, right? For those that follow generative AI, this generative AI has been around for as long as traditional AI has been around. In fact, my first patent was in generative AI in the year 2000, right? But I was concerned 7-8 years ago by the rise of the deep networks, right? These large, unexplainable, amorphous machine learning models, where if you ask the head of research, they would say, well, somehow some relationship got learned in these many hundreds of thousands of latent features, and that's why we have a good outcome, right? Inherently unplausible sort of explanation, right? And not satisfactory in our space where we're making impactful decisions such as credit scoring decisions. And so I defined 4 pillars, and these 4 pillars I'll go through. First is robust AI. Essentially, ensuring that we take a tremendous amount of responsibility in development of these models, and understanding that even though a cloud provider might be able to allow us to build a model in a handful of hours and deploy it in another handful of hours, that's not appropriate for the gravity of the decisions that these models have to make. Right? And so what is robust AI? I'll go into in the next slide, but it is focused on ensuring that we build models and understand models deeply. Explainable AI is the second pillar, right? We need to explain why a model produced a score. We all know that models can help prioritize and make predictions. They're also are very good at false positives, and they're very good at generating incorrect results. And so being able to explain what that outcome is so that a consumer can then look at the things that drove that decision from their data perspective, correct that data, or understand how to change a behavior is tremendously important. And it has to be done well. And not even well, it has to be done correctly. And so, when I talk about explainable AI, I often talk about the majority of it being bad and ugly, not even good, right? From the good, bad, and ugly movie. And what I mean by bad and ugly is that most of it simply doesn't work, and it doesn't work to the standards of regulatory purposes, including popular methods such as shopping methods. The third pillar here is ethical AI. And this is a difficult one. In some sense, we could have entire afternoon debates around what is ethics and what does it mean to be ethical. But ethical AI, every organization needs to define what that means to them. And that's why it's so important to have a model development standard that is applied across the entire organization, right? And you can go and say, for my company, this is what ethical AI means. This is what I will do to show that we are ethical in our use of AI. This is how I will show that I have proper human in the loop oversight. And this is how I will show that I have automated sort of testing and regular monitoring that the AI continues to be ethical. This is only done if you define a model development standard that you'd use for the development of these models. Which brings me to the fourth pillar here, which is auditable AI, right? These models are very, very complex. And in fact, this industry of AI model development is one of the least sort of structured environments. You think about software development processes, they're very well structured, and there's a whole science around software development. That does not apply in AI very often. And so auditable AI is showing how decisions got made, showing whether or not model development standards were actually followed, right? Not just say we have an intention to do the right thing, but to show that there's a standard that gets followed and that it was indeed followed. These auditable AI enforces that those standards are met. Moreover, it provides a record of what that model is and how it should be used and when it should not be used after it's deployed, if it gets deployed. And so auditable AI, you could think of as ensuring that the model is developed to a standard and then it is used in that standard. Now let's talk about these in a little bit more detail. Robust AI, in general, right, I would say these are building models that to not harm, right? We are trying to improve decisions and empower people in their lives, right? And we are trying not to harm people in that process. And many of us that are scientists believe that data and math and outcomes, if properly used, can make a very big impact on making better decisions, particularly credit decisions for individuals. We do not want to have that belief sullied or made incorrect by being sloppy when it comes time to build a model. And so what this means is that we need to go through an exhaustive set of steps, right, and processes when we build a model that adds such a gravity of decision impact, such as a credit scoring model. This includes things like proper problem formulation, representative historical data and demonstrating what those standards look like and publishing that, understanding what and how bias will be removed from that data, while also understanding that it's impossible to remove all of it, having a sufficient quality and volume of tags, and when we do not, right, to change our expectations for the types of models, right? Do we have enough data to build a machine learning model of any sort, right? And if so, how complex are we going to allow that model to be? Because we simply do not have enough data to train it properly. We need to focus on solid performance definitions and validating the tags, right? I see so much data that people have a good bad tag, which is not properly well defined. It's oftentimes dirtied up with other things such as fraud definitions. And, these get all thrown into a model process, becomes pretty, non-transparent pretty quickly. That's a problem. And in addition to that, we have stability and scenario testing, right? That we understand that we're building the model based on a data that is historical. As it gets deployed in production, the data will be different, right? We need to make sure that the model will continue to be performant, that it is not overly sensitive to the normal shifts in our economy or in customer behaviors that could invalidate or cause the model to be more reactive or responsive than it needs to be. In short, right, this is months and months of effort by human beings, right? This is not hours or an afternoon with a cloud provider. And so these models, right, we have to be built with a tremendous amount of care, right? And if we do that, we can develop models that are robust to changing patterns in historical data. And moreover, we can understand all the sort of steps and where these models should apply and what things we need to monitor. Now, the second pillar was around explainable AI, right? And so the other aspect of our pillars is then to say, great, we have a machine learning model. We need to be able to explain it, right? And so this is one of the sort of challenges that we have, is that as an industry, because we've had loose sort of standards of what explainability means and what interpretability means, is that, people would throw their favorite explainable AI algorithm on top of a model and say, oh, you have explanations, right? With no sort of real measure of what is a right answer, right? Or an accurate explanation. For me, this is inherently frustrating. And one of the things that I tried to do is just go down to simple basics, right? So this is a basic model, right? For those of you that are model developers, you'll recognize this as a very simple neural network. This is a neural network that has 6 inputs. It has one hidden layer with 3 latent features labeled latent feature 1, 2, and 3, and it has an output layer, which would produce a score which could be used in a decision of whether this couple gets a home or not. And when these models get trained, right, these sort of machine learning models, right, you typically have an optimization constraint such as minimizing the difference between the prediction and the answer. Okay, so the error between the prediction and the answer. And so you go and you set this model with the random weights and these little green dots. There are only 21 weights in this model. It's simple, right? It's not a huge deep learning model. And you iterate through all the data you have so that you can allow these weights to find what's called a local minimum, where the prediction error is minimized to a certain extent, and you call that a good model and you operate on it. And that model may indeed be better than your traditional scorecard and may be better than other sort of linear methods you want to use. The challenge, though, is even this very simple looking model is inherently unexplainable. And it's inherently unexplainable because the outcomes for this couple are driven by primarily these latent features. And these latent features, the things in the middle of this diagram, their purpose is to find nonlinearities between these inputs, right? So machine learning basically is based on the fact that, the data that you present to it likely contains nonlinear relationships that, if found, would allow the model to be more predictive. Right? And so when this model produces a good score for them or a poor score for them based on what they want to achieve, right? Very often there are more than one way that one of these latent features can saturate. The only thing you'll know is that latent feature number 1, let's say, is the thing that drives the score. And that's great. And you'll try to explain what latent feature number 1 is, and you'll find that there can be dozens of different paths to saturation. So if you told this couple the reason you did or did not get the score you wanted was based on the first reason that came up based on this latent feature, that might be 1 of 20. All would drive this to saturation. And so as they go to address that issue, there'd be 19 other issues which would cause them to also not be able to get the score to where they need it to be, right? And so it is not possible to explain these models, which means, right, that we are in a situation based on how this algorithm works that we have to say, it's not about explainable AI, it's about the algorithm that we use. And we have to address that. Right? We have to address that this is not an algorithm for environments where we need transparency of the machine learning model. And so what do we do? Well, we can come up with different algorithms, right? There's nothing that says we have to use an algorithm that's out, that's open source, and there's nothing that says that we have to use algorithm as it's packaged today. And in fact, here at FICO, we've introduced this concept of what's called the Highlander constraint. And this Highlander constraint is an additional constraint there in red at the bottom of the slide, which imposes that, yes, I will minimize the error between the prediction and the answer, but I'm also going to minimize the size and number of weights. In fact, I can do it in such a way that I can enforce that any latent feature can only have 1 or 2 connections. Now, why do I do this? I do this because the modes of saturation become much simpler, right? Because there are only now one or two variables that drive saturation, and I can enumerate those modes of activation. The architecture looks different. Machine learning algorithms are perfectly happy to churn out this sort of model versus the one you saw before, which is called a dense network, just a sparse network or an interpretable network like this. But this is much more important, right? This provides democracy amongst everybody that works within the banking function to look at these latent features and understand what's driving the model. And so if latent feature number 2 is driving the model, we'd know that the score, we would know that, well, that score is largely driven by a relationship between the number of collection events greater than $500 and a total mortgage balance, right? That's very clear, right? And we can indicate what that is, right? And that provides a level of transparency on what is being used in the model to drive its score. Essentially, we are opening up that black box behind the brick wall to say, these are the latent features that drive the model based on this constraint. That visibility and that inspection is super important, right? That provides that transparency that we need at all layers of reviewing these models. And they're also the same exact behaviors that we need to monitor in production to see that they're not shifting, right? Which comes to the monitoring of these models and ensuring that they're used responsibly. Now, you may look at one of these latent features and think they're really simple, and they are, right? They're 2 variables, variable 1 and variable 5, that go into latent feature number 2. But this one latent feature actually has 11 unique reasons based on whether or not V1 or V5 could positively or negatively saturate that latent feature by themselves. And so you can enumerate the activation states, and you can come up with 11 unique reasons just for LF2. And if you look at the entire interpretable neural network, which looks very, very simple, right? You can do the math. If you wanted to give just only three of the top reason codes to a consumer, there are actually 126,000 something unique combinations of top 3 reasons. So these models, which are compacting huge amounts of customer and lending data into a small set of weights, actually contain a huge number of combinations of reasons. And so it's not as simple as saying, listen, it's one of these 6 inputs that are driving your outcome for not getting the score that you initially want. It's what is learned within this interpretable neural network. And this is largely not well understood, right? And I think it's something that hopefully you reflect on, is that there's a humongous explanation capacity for even these interpretable neural networks. This brings me to the 3rd pillar, right? This is ethical AI. Ethical AI is basically this notion that machine learning is neither good nor bad, but designed to minimize prediction error, right? There's no morality to AI. And that's why we have to have human in the loop, right? Where humans are looking at the relationships that get exposed to these interpretable machine learning models. And they can make a determination, whether it be data scientists or lawyers or governance people, right? Or even, public opinion around what sort of things should be driving outcomes. Now, this is one step, right? And an important step, because by exposing these relationships, you can say, no, these relationships should not be used in the model. This model is not going to be used to provide a credit score or drive a credit decision. But that's not sufficient, right? Humans make mistakes. The quality of the people around that table may vary. Right. What we also need is an automated way to understand what drives bias. And so if we look at these sort of interpretable models, this is where we can look at different groups of individuals, right? And so one group of individuals may be feeling fine about this model. Another group may not be feeling good about that model because there might be some inherent sort of ethical issue for one class versus another. In these interpretable machine learning models, right, we're not looking at outcomes of whether or not one group or another group got a better score or worse score, right? What we're looking for is establish the criteria for what is a responsible model. And a responsible model generally would indicate that latent feature activation should not be significantly different between 2 different groups of individuals. Because if it was, for example, for latent feature 33 here, you see there's a significant difference in the distribution of activation for our blue group versus the orange group. That means that the scores would be significantly different. And we don't know if they're better for orange or worse for orange, right? But we know they're different. And we have technology today where we can simply say we're not going to allow latent feature 33 because of this disparity in how it drives the latent feature, it could lead to a disparate sort of impact when we would eventually look at a score. And so in the model development process, from an ethical AI perspective, standards are set that say that if we see these distributions of activations exceed some threshold, they're not allowed. And so it's yet another constraint that's used in the training of the neural networks, these interpretable neural networks. And so we go from networks that without ethical AI constraints, this is just an interpretable neural network, which may or may not exploit bias in data, to one where there's a set of criteria that enforce every latent feature have to abide by those latent feature ethical AI bias thresholds, and you get a different interpretable neural network. One now that has met ethical AI constraints, saying that no latent feature should have a significant difference in how it activates for one group versus another. And this is perfectly within the scope of building these models, right? Having this ability to enforce as part of the training process that the latent features will not be different amongst these groups. And ultimately, what does that mean? That means that these models, the neural network will go back and it'll train again. It'll find other latent features that do not impute bias and still solve the problem, right? There's not one solution when it comes to machine learning models, right? There's an infinite number of solutions. We need to insist from a responsible AI perspective, what are the solutions that are robust? What are the models that will be properly interpretable? And which are the models that will have ethical AI constraints imposed? And that means certain latent features will be removed. And that's fine. That's what we're trying to do. And if we do that in a human in the loop process and we have an automated process in addition to that, then we can build these models responsibly. The last pillar was the audible AI, right? This is really important to me, and I've done a lot of work in this area. I'll just say this, right? Responsible AI is not an intention, right? And it's not something you put on your website to feel good about yourself, right? It's something which is an audible trail of actions, decisions that enforce accountability. It goes back to having a model development standard, right? To actually emphasize that the development of a model is not to look at a model once a clever data scientist produced it, but to basically say, before anyone even touches data, right, we're going to set what the requirements are of a model development. We'll understand what the sprints are. We'll assign our individuals. We'll understand what the assumptions are. We'll have these success criteria for whether or not a model will be deployed. It will include things like bias detection and interpretability and the data. And then we'll go through a process that enforces that model development standard. So this comes back to this concept of organizations needing to have this responsible AI model development standard that they use and then enforce it. Now, the big piece of this that makes it auditable is that you can put all this on the blockchain. And so by putting this on a blockchain, you have an ability then to have an immutable model development process, which means that these are codified and put on a blockchain. And as you make progress, whether positive or negative along this path, this is recorded on the blockchain, which makes it very real. And it also enforces that it was actually done appropriately. Audible AI has roles, right? And this will start to look a little bit like software development, right? We have an assignee, a tester, and a verifier. We have states of requirements on the blockchain, whether they're in development or completed, tested or failed or complete, approval, failed or complete. This is a formal sort of process that gets codified on the blockchain along with names and dates and times for when these were achieved or not achieved, and showing that this standard was met. Moreover, it's an immutable record of that model development that can be used a year from now or 10 years from now to review what occurred in that model, after all the data scientists and everyone else are no longer with the firm, let's say. The way it works, right, is kind of what I've explained, right? We will have requirements such as, a requirement around bias detection and not having any more disparity than 3% in some metric around those distributions of latent feature firing. It would be established on July 7th. It would be worked, let's say, on August 18th by Jalan. She'd do the work and she thinks she has it done, and she would have reported it done on August 18th. That's recorded to the blockchain. So we know what the requirement was. That's on the blockchain. We know that she completed her work on the 18th. That's on the blockchain. Shafi here, he's the tester. On the 19th, he's testing on an out of sample, and he says, sorry, no, you did not meet the success criteria on this out of time, out of sample data set. It's not met. Failure is recorded to the blockchain. On the 26th, Jalan goes back. She updates the latent feature that was identified as having a problem with bias. She updates and she confirms no bias. She now says she's completed the task again on the 26th of August. Shafi tests again, right? This time it passes, and then I go and I review it as a final approver. And I've confirmed her work, and I've confirmed Shafi's tested appropriately. All of this is on the blockchain, and it provides that sort of level of confidence, accountability to reestablish trust in the AI process. And moreover, to enforce that model development standard so that models can be developed to the standards of responsible AI. Our customers deserve this, right? Our consumers deserve this level of rigor in the model development process. And moreover, the fact that it's immutable and every mistake and success is recorded here along with the names and the dates means that everyone takes this tremendously seriously, right? It's not meant to shame, but it's meant to go and to emphasize that we are serious about meeting these standards, right? And just show that done. And if they aren't all done satisfactory, by a process, a responsible AI process, no model is released. Okay, so if I set a success criteria that's not achievable, then that model will not be released. And that's what responsible AI is about. It's not about readjusting what you think the model should do once you examine the model. It's putting it up front and determining whether you can meet those in an objective, blind fashion, working through that process and not allowing things to adjust over time. Now, this concept of blockchain AI is very, very popular right now. I'm very pleased to see it. It's been showcased in all these sort of venues as the way to hold AI accountable. And it's a big part of what I do within the firm, and one of these areas that I think will be one of the things that will reestablish customer trust. Now, I'm nearly at the end here. The last thing I'll bring up is generative AI. I do a lot of work in generative AI. This was my first work. When I was playing with it, I decided to generate an image of an elephant in a room. And if you look closely, this is a 5-legged elephant, right? And so it was perfect for illustrating a point I wanted to make in one of my keynotes around generative AI and hallucination, which is generative AI has never seen an elephant, right? It's piecing together what an elephant looks like based on lots of data, but sometimes you have challenges with generative AI. Now, so we set ourselves, with the right expectation, right? Because there's a lot of sort of advertising and hysteria around generative AI techniques. Let's just bet ourselves very, very, very closely in this slide for a second. All a large language model is an ability to take something like 300 terabytes worth of text information, tokenize it, which means assigning symbols to groups of words or or characters in the text, embed it in a mathematical space, applies this concept of attenuation to understand the relative importance of different words into tokens to make a prediction of the very next token, and embed that in our own neural network. Spend about $2 million, get access to 6,000 GPUs, and you have that model. But the only thing that this model does is predict the next sequence, token in a sequence. There's no magic intelligence here, right? They are very effective tools, right? But that's all they do is try to assemble a response by adding the next token in a sequence based on propensities of the data on which it was trained. And so the propensity of what symbols appeared when will inform whether or not what that next sequence would be. And so any bias in the training data, of which there will be tons, because very often this data is not well understood, will show up in your large language model, which causes essentially this sort of phenomenon, which is generative AI has generated the mistrust that we're dealing with today, right? We have examples where Stanford said that in queries of our court rulings, LLMs hallucinated 75% of the time. There was a very interesting study done that said that ChatGPT treated black and white sounding names very differently, and then it would lead to disparities in terms of, let's say, offers made to black versus white customers. New York City has, put out chatbots, right, that talk about the fact that it's still okay to serve cheese if it had rat bites in it. And we have lawsuits with Air Canada held liable for lying AI chatbots, right? And so we look at this as, these sort of examples of huge amount of concern with generative AI, right? And I am concerned as much as I am a researcher in these areas about the use of AI, generative AI, in making these high impactful decisions. Now, this is the quote that I tend to like, and it's from American Banker, and it simply says, there are practical uses for generative AI, right? They include generating summaries of calls and giving employees co-pilots potentially, complying with loan rules, and maybe coding some new core systems, right? But the quote that I like the most is, so far, we've not seen these go directly to customers when it comes to banks. And that's because responsible banks understand that there are big concerns with allowing these technologies to inform consumers where we have very little understanding of how the answer was generated and the data on which it was built. What it means is that generative AI probably won't be one of the first things that drive credit scoring, right? It may be used in our back-end processes, but we need to see a transformation in terms of a convergence between responsible AI and generative AI, which will be something that may take 5 or 10 years, maybe longer. And it'll be something that looks very different than the large language models that we know today, which is a frontier which I call responsible generative AI, where we have confidence that we can leverage these technologies to reach customers, but in ways that are guarded and responsible and we have better control of. With that, I want to wrap with my favorite quote. All models are wrong, but some are useful, by George Fox. I think as we look at trust in AI and the use of AI, we need to understand that models are wrong, and they're very often wrong, but they can be very, very effective tools. And so it's on us as practitioners, as we try to leverage these phenomenal technologies to improve credit scoring, for us to define what useful means, whether in terms of prediction, in terms of explanation, in terms of ethics, in terms of fairness. And that's a lot of work, right? But I hopefully this helped give some illustration of how a path that we believe is one that one can use to get there. Thank you.
Thank you so much, Scott. Excellent presentation. If we may take a minute to ask one question, we just have about a minute left, and the question that comes from the chat is, how can a regulated bank use a black box for decisioning customers when there is consumer protection?
Yeah, I don't think they can, right? And so we need to define what a white box looks like, right? And so when I shared this interpretable neural network technology, and the fact that we have blockchain, one of the reasons we use these blockchain technologies, this audible AI, is that when these models get developed, all those latent features would be recorded to the blockchain. And so there's a visibility which could be provided, right, through permissions, where a regulator could get access to, these are the 10 latent features that drive the model, right? And this is how they drive the model, right? And that is the level of transparency that frankly, I think is required, right? And it gets us to a point of understanding that these are tools, not, super protective IP. And so I think those are the methods and sort of processes that we have to discuss as an industry around, let's say, allowing regulators to have access through things like that audible AI blockchain, to have access to some of that core IP and information, so they can feel comfortable and understand how they'll be monitoring those models and whether or not standards were followed.
Oh, thank you so much, Scott.